Welcome everybody to lesson 3.3. Today we're talking about interest as an exponential function. So interest is something that you gain on savings accounts, bonds, things like that slowly increase in value over time. So let's get cooking talking about interest. So Heaven has recently started making money selling dog hair to Anaya. We know how much Anaya loves her dog hair collection. Made her a lot of money. So let's say that Heaven has $5,000 to put into a savings account and is deciding from each of the three options below. So what we're going to do today, so each of these three options, what happens is there's an interest rate. So like in the first account, it's 3%. The other two accounts is 2%. And then it tells us how often interest gets compounded. So for example, option A says interest compounds quarterly, which means 4 times a year at a rate of 3%. What that means is roughly every 3 months, Heaven's $5,000 will grow by 3%. And then that'll happen again the next 3 months and the next 3 months. So interest is compounded quarterly at a rate of 3%. Option B, compounded monthly at a rate of 2%. And then option C, compounded continuously at a rate of 2%. So today we're going to discuss how to write an equation to model each situation and then help Heaven choose the best way to save her dog hair money. All right, so this is the formula for compound interest. So in general, this is the formula for compound interest. So A is the amount of money in the account. P is the principal amount. This is basically the initial deposit, how much money you put into the account initially. R is the rate that interest is being compounded at, and this is expressed in decimal form. So for example, for these, rate of 3%, R over here would be 0.03. N is the number of times interest is compounded per year, and then T is the number of years elapsed. So we're going to look at each of these and we're going to write an equation for it. So for each of these, so we've got A, the amount equals, first we've got P, which is the principal amount. So if we go back and look, Heaven is initially depositing $5,000. So for all of these, the principal will be 5,000. All right, times 1 plus R over N. So R is 0.03 because that's our interest rate. N is the number of times per year that the interest gets compounded. So if it's compounding quarterly, then N would be 4. And then this is going to be raised to the power of N times T. So that's going to be 4 times T. And notice we don't know what T is actually equal to because we don't know how long Heaven is actually going to be investing this money. So we're going to leave it like this. And right now, the amount of money in the account is a function of the amount of time, the number of years that Heaven leaves money in the account. So for option B, a lot of stuff is going to be similar. She's still investing $5,000. All right. And then it's still 1 plus, this time the rate is 0.02. And instead of being compounded quarterly, which is 4 times a year, we're going to compound monthly, which we know there are 12 months in a year. So this is going to be over 12. And then this is going to be to the power of 12 times T. So again, the amount of money in this account is going to depend on how long Heaven leaves the money in the account. So option C is something a little bit different because if we try to use this formula for option C, this is going to be 5,000 times 1 plus 0.02 over, I don't know. So the problem is it's being compounded continuously. So there's not a certain number of times that this happens per year. It's just always happening, which means really the number of times is being compounded is like kind of infinite because it's always happening. So I'll spare you the explanation of how this happens, but compound interest specifically, continuously compounded interest has its own formula. So continuously compounded interest has this formula, and it's very affectionately referred to as PERT. So this is the PERT formula. This is for continuously compounded interest. So it is P times E to the RT. So A is still the amount in the account, P is still the initial amount, R is still the interest rate expressed as a decimal, and T is still the number of years elapsed. But E is not a variable. E is not something that I'm plugging something in for. E is an actual number. So you know how there's like pi, which is like 3.14 and a whole bunch of other stuff. E is an actual number that's about equal to 2.72. It's actually like 2.71828 and a whole bunch of other stuff. So your calculator has a button for E. So what we're going to do is we're going to look at how to do this continuously compounded interest along with the other two, and we're going to write an equation for all of them. I'm waiting for my calculator to pull up so I can show you how you can put E into your calculator. All right, so if you look at your calculator, if you notice right over here above the division sign, if you press second and then the division sign, it puts up E and it gives you the value for E. Also, if you want to raise E to a power, if you notice down here above ln, if you press second and then ln, it'll ask you to raise E to a power. So like E to the fifth is 148 point some other stuff. All right, so we're going to look at writing the equation for this. So we've written the equation for the first two. So now for the third one, if I have interest compounded continuously, this would be A equals P, which is 5,000 times E to the R, which is 0.02 T. All right. Oh, sorry, I went the wrong direction. We're going to go and write it on the page with the other formulas. So this, instead of having this stuff here, this is 5,000 times E to the 0.02 T, where again, T is the number of years that Heaven has kept the money in the account. So the last thing that we're going to do today is we're going to figure out which account is going to have, or how much money she's going to have in each account in 3.5 years. So right here, A was equal to 5,000 times 1 plus 0.03 over 4 to the N, which was 4 times T. So in this case, T is 3.5. So we're going to put 3.5. All right, here, A is equal to 5,000 times 1 plus 0.03 over 12 to the 12 times 3.5. All right, and then down here, this is 5,000 times E to the 0.02 times 3.5. All right, so we're going to figure out what each one of these is approximately equal to. So the reason that I'm doing this, typically I don't do stuff like this in the video, just these calculations, but I want to make sure that we know how to use the calculator, specifically with E. So if I type this in, this is 5,000 times 1 plus, I'm not going to use parentheses for this because I know that my calculator knows the order of operations and will do this the right way. But if you want to be careful, if you press alpha F1, if you have one of these newer calculators, you can do N over D. And you can put this in as 0.03 over 4. All right. And then to the power of 4 times 3.5. All right, so we can put this in our calculator, press enter. So this is about $5,551.38. So this is about $5,551.38. All right, so now let's look at the next one. Compounded monthly. I'm going to do the same kind of thing. This is going to be 5,000 times 1 plus. I'm going to type it in as a fraction again. So this is 0.02, not 0.03. Sorry, I wrote 0.03 over there. Over 12 to the 12 times 3.5. All right, and this gives us about $5,362.23. This is about $5,362.23. Let me also change that real quick before I confuse anybody. This should say 0.02 because it's an interest rate of 2%, not 3%. And then for the last one, we're going to do 5,000. Again, if I want to raise E to some power, I'm going to press second ln. Now my calculator says E to some power, so it's going to be 0.02 times 3.5. And this gives me about $5,362.54. So as you may have suspected initially, the one with the highest interest rate is actually the one that will have the most money after 3.5 years. So that is it for today's video. Today we talked about interest and compound interest, how to write the equations, and then what some problems will look like involving those. So I hope you took some notes. I hope you come to class with questions, and I hope you have a fantastic day. I'll see you in the next video.